In this video, I'd like to talk about complex numbers from their absolute value and their angle. And essentially with these examples, we will be given the magnitude, the modulus or the absolute value of the complex number, and the angle of the complex number, essentially its direction. And remember that this angle is measured from the positive real axes in the complex plane. And we need to express the complex number in its rectangular form, which is the usual way that we write these, where we have a real part and an imaginary part. Essentially, we need to take this complex number in its polar form and rewrite it in its rectangular form. And remember that for some complex number with real part A and imaginary part B, we can essentially plot this on the complex plane where the length of the line here, this distance from the origin, its absolute value, can be written like so, and its angle is measured from the positive real axes. And we can construct a right triangle where the vertical component would have length b, the imaginary part of the number, and the horizontal component will have length a, and we can use trigonometry to relate the sides a and b to the angle and the magnitude. In fact, using the cosine function, we can find that a, the real part, is equal to the magnitude of the complex number z multiplied by the cosine of the angle. And all of this was derived in a previous video on the polar form of complex numbers. And b here, similarly, we'll use the magnitude of the complex number z, but this time we'll multiply by the sine of the angle. Since remember the trig definition, so katoa, the cosine deals with the adjacent divided by the hypotenuse. You can imagine just divided by absolute value of z and then multiplying both sides by that to solve for a. And likewise, the sine of theta deals with the opposite divided by the hypotenuse. And again, this originally was right here, and we multiply both sides by that magnitude of z. And from here, we can plug both of these expressions for a and b into our rectangular form, so that z1 is the magnitude of z multiplied by the cosine of the angle plus I times the magnitude of z multiplied by the sine of the angle, and we can factor out the magnitude of z, this absolute value of z, so that we get the cosine of theta plus I times by the sine of theta. And from here, we can essentially plug everything we know about the complex number into this equation and then simplify it into its rectangular form. So let me make a little bit of room, and we can plug in what we know in terms of the magnitude and the angle. And we can actually just use this top equation here since we'll have to distribute this in the end anyways. So we have that z1 is the magnitude of the complex number, which is 12, multiplied by the cosine of 163 degrees, plus I multiplied by the magnitude of our complex number, which again is 12, and multiplied by the sine of 163 degrees. And we just need to plug these expressions into the calculator and simplify. And since we are in degrees, make sure your calculator is in degree mode and not radian mode. And we will have to round a and b to the nearest thousandth. So when we plug 12 times the cosine of 163, we get back minus 11.4756 or 476. And for the imaginary component, 12 times the sine of 163, we get 3.508. And the way to quickly check this is to sketch this number on the complex plane. It has a real part of about minus 11.5, and it has an imaginary part about 3.5i. So it should be right about here in the complex plane. And we can figure out its magnitude by using the formula for the magnitude, essentially using the Pythagorean theorem if we drew a quick right triangle here. And we would get the square root of the real part plus the imaginary part, and we're squaring both of those. And what we would find is that this magnitude of z would be 12. But that is one way to verify the magnitude. And for the angle, you can verify this visually, since 163 degrees is slightly less than 180, and 180 would go all the way down to the negative real axis. So the angle looks to be correct, and the magnitude, if you plug these in, square them, and add them together, and then take a square root, you will find that this magnitude is 12. So there are ways to check your work here to verify that you're doing this correctly.